Hello everyone, welcome to Basic Electronics Tutorials. In this video, I am going to take up the first numerical on diode biasing. Let me read out the question first. An AC voltage of peak value 20 volts is connected in series with a silicon diode and a load resistance of 500 ohms. If the forward resistance of the diode is 10 ohms, find part A, peak current through the diode, part B, peak output voltage. What will be these values if the diode is assumed to be an ideal diode? Right, the question is quite simple here. We have an AC voltage source connected in series with a diode and a load resistor. The peak value of the AC voltage source is 20 volt and the load resistance is 500 ohms. Also, the forward resistance of the diode is said to be 10 ohms. Let us start the solution part by writing the circuit for the given configuration. Coming back to the question, note that the AC voltage has a peak value of 20 volts. So, let me now very quickly draw the sinusoidal voltage for this configuration. Right. The first diagram here, which is to the left, is the input voltage waveform, and the second one, that is to the right, is the circuit for the given configuration. The output voltage appears across the load resistance RL. Since we are asked to find the peak current through the diode, it is now useful to draw the piecewise linear equivalent model for the diode and thereby reconstructing the circuit with the piecewise linear model. Let me now very quickly do that here. Right. So, what I have now done is I have replaced the diode by its linear piecewise equivalent circuit. I have discussed about the diode's linear piecewise equivalent circuit in one of my videos. You can watch it by clicking on the link shown in the top right corner right now, or I will leave the link of the same in the video description below. You should note that in the linear piecewise equivalent circuit, the diode is replaced by a battery with a voltage equivalent to its knee voltage or turn-on voltage or threshold voltage, and a resistance which is equal to the forward resistance of the diode. Now, we are ready to find the values asked as per the numerical, but before that, let me now very quickly list out the given parameters. We are told that the peak input voltage is 20 volt. Let me represent it by V in max. This is equal to 20 volt. The diode forward resistance is 10 ohms. It is represented by RF. Load resistance is 500 ohms. And the turn on or knee voltage of the diode is 0.7 volts. Right. Let us now start with the part 1 of the numerical, which is to find the peak diode current. We should note that the peak current through the diode will occur at the instant when the input voltage reaches the positive peak value, that is V in is equal to 20 volts. I am going to denote the maximum value of input voltage as V in max. Coming back to the circuit shown in the second figure here, which includes the linear piecewise equivalent circuit, let the current through the diode be represented by IF, indicating forward current. Let us now apply KVL to this circuit. When I apply KVL to this circuit, what we will obtain is V in minus VT minus of IF into RF minus of IF into RL. But please note, we are currently at the scenario where V in is equal to V in max. So, the input voltage will be replaced by maximum input voltage and the diode current will be replaced by peak diode current. So I will write it as V in max minus of Vt, which is the threshold voltage or knee voltage of the diode, minus of If peak multiplied by Rf plus If peak multiplied by RL. Let me rearrange this equation. Since we are asked to find the peak diode current, I will once again rearrange the equation for If peak. Let this be equation 1. Let us now substitute the values in equation 1 and find the peak value of the diode current. V in maximum is 20 volt, Vt is 0.7 volts, Rf is 10 ohms and RL is 500 ohms. Let us solve this. The numerator will reduce to 19.3 and the denominator will reduce to 510. Therefore, the peak value of the diode current is equal to 37.8 milliamperes. That is the solution for part 1 of the numerical. Let us now move on to the second part of the numerical, which is to find the peak output voltage. The solution for this is pretty simple. Let us go back to the circuit now. Note that we have now found the peak value of the diode current. Now, since this is a very simple series connected circuit, the current that flows across the diode is the same as the current that flows across the load resistance as well. Therefore, the peak output voltage is simply equal to the value of the load resistance multiplied by the value of the peak current flowing across the circuit. This current is nothing but the peak diode current. Therefore, the peak output voltage can be written as V out maximum equal to If peak, which is the peak value of the diode current, multiplied by load resistance RL. We just found If peak as 37.8 milliamperes and the value of RL is 500 ohms. Therefore, the peak value of the output voltage is 18.9 volts. That is the solution for part 2 of the question. Coming back to the numerical, let us look at the last sentence of the numerical. It says what will be these values, that is the value of the peak current through the diode and the peak output voltage if the diode is assumed to be ideal. So, I will state the condition as for ideal diode. You should note that when the diode is ideal, the voltage across the diode that is required to turn on the diode is 0 volts. So, the value of the knee voltage will become 0 volts. Also, it does not offer any resistance to the flow of current across the same and therefore, the forward resistance will also become 0. Let us now write that down here. Right. So, all we now need to do is to simply substitute these values into equation 1 to find If peak and to equation 2, which is for V out max, to find the peak output voltage. Let us now do that here. Let us substitute into equation 1 first. V in max is equal to 20 volt, Vt is 0 divided by Rf is 0 and RL is equal to 500 ohms. So, the peak value of the diode current now becomes 40 milliamperes. Now, I will move on and find the peak output voltage. So, substituting into equation 2. For the If peak value, you need to now consider the value of the peak current when the diode was ideal. So, If peak is now 40 milliamperes and the value of RL is 500 ohms. So, this will reduce to 20 volt. If you look at the value of the output maximum voltage, you will now understand that the diode is in absolute ideal condition and the output voltage and the input voltage are exactly the same. Well, with that, we have come to the end of this numerical. In my next video, I'll take up another numerical on the diode biasing. So stay tuned. If you liked this video, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.